Hi, everybody. So we're going to take a look at solving some quadratics. So we've done quite a bit so far in terms of vertex form, finding the vertex, whether we're given the factored form or vertex form or standard form. And then from there, we did some max and min word problems. But sometimes some of our questions don't ask us to want to actually get the vertex. They want to know what the actual x-intercepts are. So when you see something that says solving quadratics, the word solving means what value for x does it make it true? And in this case, it's your x-intercepts. So that's what we'll be looking for. So, we'll give it different forms, we'll use different things. But just a reminder, one of the things that we did use when we were solving quadratics was the quadratic formula. And I don't know if you remember the quadratic formula, but if not, I have this little video clip. And let's see. There we go. If you had math with me in grade 10, you might remember this. Okay, there you have it. There is the quadratic formula song. So if you want, you can play that over and over and over again until you're sick of it so that you can remember the formula. Okay, but since we're open book this year, just write it down somewhere so that you have it. Okay, so we can solve an equation by finding our x-intercepts. And if your equation is in factored form, then it's just a matter of taking each one of your factors, in this case x plus 3, and putting it equal to 0 and solving for x. So x equals -3 must be one of my solutions, and then my other solution, 2x minus 3 equals 0. I would add 3 to each side, so 2x equals 3, and then divide by 2 and divide by 2. So x equals 3 over 2. So my two solutions then that work in this equation would be x equals 3 is one solution, and x equals 3 over 2 is the other solution. Okay. But what if it's not in factored form? Well, if it's not in factored form, that's when we're going to look at it and say, whew, I hope I can factor this. So two numbers that multiply to negative 10 but add together give me positive 3 are going to be a positive 5 and a negative 2. And I'm going to take each one of those factors and set them equal to 0 and solve for x. And look at that. I have two solutions here. X equals negative 5 is one of my solutions, and x equals 2 is my other solution. Both of those would work in the equation, making it true. If I put in a negative 5 into my equation, I end up with negative 5 plus 5 in my first set of brackets, which is 0. And 0 times anything is still 0. So that would work. And then if I put a 2 in my second set of brackets, I get x plus 5 times 2 minus 2. And 2 minus 2 is 0, so x plus 5 times 0, which is also 0. So both of those work. Okay. What if we had something like this? So this is hard to really even think about. Like, how can I get x squared plus 36 equal to a negative 13x? So what you want to do is you want to move all your terms over so that they're on one side of your equation. So I'm going to, whoops, rewrite that. I'm going to do x squared, and then I'm going to move this negative 13x over where it becomes a positive 13x plus 36 equals 0. And now look at that. I have a quadratic equation. I have all my terms on one side, and I have it equal to 0, which means I can go ahead and factor this. So two numbers that multiply to 36, but add together give me 13, are going to be a positive 9 and a positive 4. And again, it's a matter of just taking each factor and setting it equal to 0 and solving for x. And in this case, we get our two solutions to be negative 9 and negative 4. All right, let's try this one. Oof, this one's a little bit harder. Of course, we have that 6 in front, so 6x squared plus 2x minus, or plus x minus 2 equals 0. This is going to be some decomposition. So go ahead and use some decomposition. I'm just going to do a little bit of trial and error here. I know I have negative 2 in the end, so I know that I want the final numbers to be a 1 and a 2 because that's how I'll get it. And one's going to be positive and one's going to be negative. What multiplies to 6? Well, 1 and 6 do, but I feel like that my numbers won't get me to a positive 1 as my middle term. So I'm going to try 3 and 2. And if I put a 3x here and a 2x here, then this becomes 3 and this becomes 4. So I'm saying it but not showing you. This times this is 3 and this times this is 4. So 3x and 4x. But if I had a positive 4x, so positive 4x, but a negative 3x, that would bring me to my positive 1x. So that must factor to 2x minus 1, 3x plus 2. Of course, you could have done decomposition on that and gotten the same thing. Now, we're going to take each one of these factors, put them equal to 0. So 2x equals 1, divide by 2, x equals a half. And then 3x plus 2 equals 0. 3x equals negative 2. Divide by 3, x equals negative 2/3. So that one definitely was a little bit harder because we had to use decomposition in order to figure it out, to factor it. Okay, last one here on this side. Ooh. Now this looks really big and messy, but actually it's not too bad. We're going to start by getting rid of our brackets. So to do that, I'm going to take what's outside my brackets and I'm going to multiply it into everything inside the brackets. So I get x squared plus 6x equals negative 6x minus 32. And then I'm going to move everything. So x squared plus 6x stays here. And now I'm going to move this negative 6x over. It becomes a positive 6x. And I'm going to move the negative 32 over where it becomes a positive 32 equals 0. All right. And then I can combine my middle term to give me 12x plus 32 equals 0. So this is going to be x plus 8. Two numbers that multiply to 32 but add together give me 12. X plus 8 and x plus 4. And once again, set each one of those equal to 0 and solve for x. And my two answers would be -8 and -4. So we had to get rid of our brackets and then move everything over to the other side so that we got it equal to 0, and then we factored it. So factoring is great. Like if you can look at it and be like, oh, I can factor that, then this is definitely will work, you know, if it's factorable. But the problem is that it's not always factorable. So what if we have something like this? X squared plus 3x minus 9 equals 0. I'd like to factor it, but I can't think of two numbers that multiply to -9 that also add to 3. And there aren't any. That's why I can't think of any. So I'm going to have to use my quadratic formula. So hopefully you already have this somewhere in your notes. But if not, feel free to copy this down. For any quadratic equation of the form ax plus bx plus c equals 0. So notice, this is standard form. There's no brackets. And all your terms have to be on one side. It has to be equal to 0. Then we can use a quadratic formula. And our quadratic formula, if the song is not stuck in your head, is -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So there's our quadratic formula. Just a matter of taking our numbers, our leading coefficients out of the equation and putting them into the proper spots. So for a, I have a is equal to 1 because there isn't a number there. It's assumed to be a 1. B is 3, and c is -9. So if I was going to put this into my quadratic formula, I put a 3 in for b. So it was a positive 3, but once it goes in, it becomes a -3 plus or minus 3 squared minus 4ac, all divided by 2a. So 2 times 1, which is going to be -3 plus or minus the square root of, okay, 3 squared is 9. -4 times 1 is -4 times -9, which is going to be a 36, all over 2. So -3 plus minus the square root of 45, all over 2. Now, the square root of 45 is the same thing as 9 times 5. So I can simplify this a little bit. So this is where our radicals come into play. 9 times 5 is 45, which is going to give me -3 plus or minus 3 root 5, all divided by 2. Now, we can't simplify that any further. We can't divide. Well, first off, we can't combine the terms on the top because one of them has a root 5 and one of them doesn't. And we can't simplify the numbers because my denominator is a 2, which doesn't go into 3 evenly, either 3 evenly. So that doesn't work. So we'll just leave it like that. We don't put decimal answers anymore. We just leave it. That is expressed in exact form, and so we just leave it right there. The only time you would go ahead to find the decimal answer is if you had a question that already had decimals in it and it wanted you to find, like, when does the ball hit the ground to the nearest tenth of a second type thing. Then you would use it. Okay, let's try one more. So let's say this one. I'm actually going to, cut this and put it on a new page so that we have room to see it. Oh, did it work? Just a sec. Let me go back. Oh, and now I've lost it. That's not good. All right. There it is. All right. Copy. Nope, not there. Oh, it won't let me. Oops, and I don't want that either. Sorry, this is the problem, but I'm not going to start re-recording. So I'll copy it in my head. Negative 2x squared plus 8x minus 5. Negative 2x squared plus 8x minus 5 equals 0. So we're solving, this is the whole point, is that we're solving for x. I could try to factor that, but it doesn't look like it's factorable. So I'm going to say no to factoring, and instead I'm going to say yes to my quadratic formula. Okay, A in this case is a negative 2, B is an 8, C is a negative 5, and I can go ahead and put those numbers in. So when I put an 8 in, it's going to become a negative 8. Remember, it changes signs. 8 squared minus 4 times negative 2 times negative 5, all divided by 2 times negative 2. So negative 8 plus or minus 64, because that's 8 squared. Then negative 4 times negative 2 is a positive 8. Positive 8 times a negative 5 is going to be negative 40 all over negative 4. So negative 8 plus or minus the square root of 24 all over 4. Negative 8 plus or minus. All right, 24 is the same thing as 6 times 4, or 4 times 6. And the square root of 4 is going to be 2. So 8 plus or minus 2 root 6 all over 4. Now, when you go to simplify this, which you can, because you notice the 8 is an even number, the 2 is an even number, and the 4 is an even number, they all have to divide into each other in order to simplify. So I can't just divide the 4 and the 8. Like, that is not allowed. Mathematically, it's not allowed, because technically, this is what you have. Okay? So it's almost like you can split it up. So the 4 has to be able to go into the 8 and into the 2. So we can divide everything by 2. So let's divide everything by 2, which would give me negative 4 plus or minus 6 all over 2. So I could divided this by 2, divided this by 2, and divided by this by 2. So all your coefficients have to be able to be divisible if you want to simplify it. And that would be my final answer. Okay, so the nice thing about solving a quadratic, all your terms have to be on one side, has to be in standard form. But if factoring is not your strong suit, then your quadratic formula will work as long as you don't make any numerical errors. Okay, and then remember, we're going to leave it as a radical because we know how to use radicals now, but also because it keeps it in exact form. All right, almost to the end. So let's talk about the number of solutions. So when we talk about the number of solutions, really we want to know how many x-intercepts. All right, and if I think about the graph, okay, I could have 2 x-intercepts, so I would have one here and one here. I could have 1 x-intercept where it only hits it once, or I could have no x-intercepts, so where it doesn't cross the x-axis at all. So there can be 2 solutions, there could be 1 solution, there can be no solutions. So when we just want to know the number of solutions, we just want to know basically, you know, is this graph going to cross 2 times on the x-axis, once on the x-axis, or none? And the way that we do that is through the discriminant. So the discriminant is just a part of our quadratic formula. It's the part that's under the square root sign, the b squared minus 4ac. And you plug your numbers into the discriminant. And if you get a positive number out, something greater than 0, it means there's 2 solutions. If you get something that equals to 0, then there's 1 solution. And if you get something from b squared minus 4ac that's negative, then there's no solutions. So just like before with the quadratic formula, you want to list out your a, your b, and your c, but this time you're only using just a little smidgen of that formula, b squared minus 4ac. So 5 squared minus 4 times 3 times negative 9. which is going to be 25 plus negative 4 times 3 is negative 12. Negative 12 times a negative 9 is going to be a positive 108. And then if I add that to 25, gives me like 133. Okay, the number itself is not important. It doesn't mean anything. Just the fact that it's positive means that there would be 2 x-intercepts or 2 solutions to our problem. Okay, so let's try B. So A is negative 1, B is a positive 3, C is a negative 7. Again, I'm just using part of that formula, just the b squared minus 4ac. So 3 squared minus 4 times negative 1 times negative 7 equals 9. Negative 4 times negative 1 is a positive 4. Positive 4 times negative 7 is negative 28, which is going to give me negative 19. Again, it's not the actual number, it's the negative part. Tells me that there are 0 solutions to this. So this would be a parabola that opens up above the x-axis or opens down below the x-axis. Okay. Now, negative 2x plus 3 squared minus 5 equals 0. You could expand this whole thing out because it is not in standard form, so we don't know our a, b, and our c. So you could definitely expand this whole thing out, collect your like terms, get it in standard form, then put it into your discriminant. But we can be smart about this and recognize this is actually in vertex form. And we like vertex form because it tells us exactly where the vertex is. So my vertex is at negative 3, negative 5, which is like down here. And then I can tell from the negative sign out front, that negative 2, that this is a parabola that opens down. And so if I just actually do a quick little drawing of this, I can see this is a parabola opens down below the x-axis, which means it's never going to cross the x-axis. So once again, this has 0 solutions. I don't know why I wrote out the word 0, but I did. Okay, 0 solutions. So it has to be in standard form for sure, but sometimes we can cheat a little bit. And instead of using our discriminant, maybe if we just draw a quick little sketch of the graph can tell us what we're looking for. Okay, so the discriminant helps us see how many solutions. It does not tell us the actual solutions. It does not tell us the answers, the x-intercepts or the zeros or the roots, but it does tell us how many we can expect to find. Okay, challenge question. So determine the values of k such that the quadratic equation has exactly 1 solution. Okay, so here's our big hint. Exactly 1 solution. When they're telling me how many solutions to expect, then I know I'm using my discriminant. And my discriminant has exactly 1 solution when it's equal to 0. So b squared minus 4ac equals 0. Well, in this case, a is equal to 8. B, I don't know. It's equal to a k. And c is equal to a 2. So let's put this in. And I get k squared minus 4 times 8 times 2 equals 0. K squared minus 4 times 8 is 32. 32 times 2 is 64. Equals 0. I'm going to solve for this. So I'm going to move that negative 64 to the other side where it becomes a positive 64. And then to get rid of my square root, get rid of my squared, I'm going to take the square root. And I get k equals, look at this, plus or minus 8. There's actually 2 solutions here. Don't fool yourself and think there isn't. Okay, when you take the square root of the number, it can be either positive or it can be negative, either one. So in this case, it's a plus minus 8. There are 2 solutions. All right, so the best bet now is to practice this stuff. So if you go to page 49 in your book, you can practice your quadratic formula. You can practice using your discriminant. And then we should be good to go for word problems, which are coming up next. Thank you.